tokenization. So we went through the basic code for doing string tokenization. So now we'll build on top of it and see another example. Again, we are still not looking at an application of a stack, but this will be useful to again see how we apply that basic code that we saw last time for string tokenization. Okay. So what we want to do in this example is given again expression which is a string comprising some integers and symbols. We want to count the number of symbols and sum all the integers in that expression. Okay, so you include the string and C-string header files along with the IO stream header file, and include using namespaces to do all the regular stuff. So I declare a string object, say I call it a sample. So string is a built-in class. So sample is the name of the object I'm creating of class string. So ask the user to enter an expression. So I use the getLine function to input a string, because here I could have blank space and all those stuff. So I use the getLine function to input a string. So it takes two arguments, the cin and the sample, the string object name. So in order to do string tokenization, we need to have a character array storing the contents of the string. So we will create a character array. So we'll use a pointer to create an array here. So we need to know the length of the string. So sample.length will give us the length of the string. We could use sample.size. So size and length, either one of the two functions we can use here. So last time, as I said, when you represent a string as a character array, it becomes like a C-style string processing. So we need to create one more character space to include this \0. So that will be the last character for the character array representing a string. That's why we say a +1 here. So that's the size of the array. So we use a pointer. So sample array is a pointer to a character array. Then we want to copy the contents of the string which is in the sample to this block of array representing the characters. Okay, so we use a c_str function. We call this a function in the string class. We can call that, and that will generate a character array of the string. So that will be the contents of that string will be now also in this block of character array that we just created for the characters. So then we can start our string tokenizer. So strtok is a function that we can use to start the string tokenizer, and we pass the sample array, the character array, as the argument, and of course that's a pointer to a character array, and then the set of delimiters. So this is where you include all the delimiters that will be part of your expression, and that will be used to kind of separate the tokens from each other. So you can have the comma, blank space, and any other delimiter we want. So in this example, I want to just count the number of symbols in my expression and sum all the integers in the expression. So again, I want to count the symbols, so I need to specify which symbols I need to count. So those symbols are not part of the delimiters. So what you specify here are not going to be those symbols. So comma, blank space are not considered part of the symbols in this example, because we're going to use them as delimiters. Alright, so this CPTR, as I said last time, is going to point to the first character in a token until you see a delimiter. Everything will be now kind of, once you call that CPTR, we can get that as a set of characters. So I check if my CPTR is null. If it's not null, I can get inside a loop and start traversing the string character by character. So I create my first string. So again, this is the class name, token is the object name, and I pass CPTR as the argument. So CPTR is pointing to the first character in that string. So when you do that, what happens is the set of characters starting from that character where CPTR is pointing to all the way to the character before the delimiter will be extracted out of the string and uh, uh, created as another string of name token. Okay. So now we are checking if that string is either any of the symbols. So remember, it could be some expression like this. So I could have, say, an at here and some other symbol. So I want to count here the number of symbols. So I could include some symbols like this. So if the string I extracted equals that, so even one character could be considered as a string. So that's why when you put here inside the as the argument for the compare function, you put that character inside double quotes. So when you put things inside double quotes, they are considered as a string. So you are trying to check if the string you just extracted is at, or this symbol, or this one, or this one, and this one, and so on. So now this compare function is a built-in function in the string class. Okay, so once you include the string header file, all these functions can be used. So the compare function returns a numerical value. If the two strings you are comparing, so token is also a string, and what you pass as an argument is also a string. So if the two strings you are comparing, or the content wise they are the same, then it returns 0. If the two strings are not the same, it returns a value other than 0. So if you go through the details of this compare function in that C++ reference website, which I showed you some time back, it will tell you, so if the return value is greater than 0, I think the first string is kind of, what do you call, lexicographically, according to the dictionary, ordered, is greater than this one. Okay, so it means this symbol inside the compare function will appear first in the dictionary compared to this symbol token. If the return value is kind of less than 0, it's the other way. So, but we don't need to know those details. We just want to check here equal to 0. So if it's equal to 0, then the two strings are the same. That's what we are interested at. So if the content inside the token could be any of those symbols. So we need to put an OR operator here to check if this is true, or this is true, or this is true, or this is true. So it could be any of those symbols. So if any of those symbols are encountered, the whole condition will be true, because we just have an OR here. So then we come inside the if block and just increment the number of symbols. Else, that means if it did not encounter a symbol. Now I am assuming here the user enters only an expression that has either integers or any of these valid symbols. Okay, so that's why I simply have an else block here, where I assume it's going to be an integer. So again, there's an stoi function that is part of the string class you can use to convert whatever the contents of the string to an integer. So the string, so like I indicate here, would be 1, 5 set of characters. That's the string 1, 5. So you want to now convert that to an integer 15. So we can call this stoi function that will convert that string 1, 5 to 15, and now that's stored in this temporary variable value. And you can keep adding that to the initial local variable some integers that you have created here, and that will keep adding all those integers. So this is now the first token that was extracted from the string. Now you want to move on the CPTR to the next token. So this is how you move the CPTR to the next token. So strtok, the string tokenizer function. Now when you want to move it further down the string inside this while loop, you don't specify the name of the character array or the pointer to the character array. You just specify null and then the set of delimiters you want to use to extract the next token. So if you stay consistent across the entire expression, you can specify the same set of delimiters. Okay, but technically the delimiters you put here will be the set of delimiters you want to use after the first token is extracted. Okay. but we'll just keep it simple and say use the delimiters across everything the same throughout the expression. So we use blank space and comma typically to make it visually clear what are the tokens we want to look at. Alright, so the null specifies we want to kind of traverse through the string until we see this \0, which is this end of the string null. So that's why you specify null here as the argument. So if we have not reached null, like in this case it will be this @ symbol, so then we can extract the next symbol, and in that case it will be equal to this symbol here, so the number of symbols will be incremented, and keep doing like that until CPTR is now null, and that's the time CPTR will be null, and you come out of the while loop and you print the number of symbols or operators, whatever you want to call, and the sum of the integers. So this code is available number 3.5 in the zip file I posted in Canvas, so you can download and play with this code and try different things you want. Okay, any question on this example? Okay, so let me save this. Where is my